Hello everyone, how are you doing? I record my entire video without pressing the record button, so now I have to redo my entire video, which is kind of bad. But anyway, I think I should be able to do a better job now, I hope. So for this problem, I want you to determine the resultant magnitude and direction for the following vector diagrams. So pause the video, try yourself first before you continue on watching. Yeah, let's try to make it more interesting now that I do the 1,000th time recording this. Anyway, okay. So you need to draw the resultant line first from the tail of one vector to the head of another. That will give me the resultant, and we need to find the angle, okay, magnitude and direction. Direction is referring to the angle. So look at this, you probably notice that it is a squared plus b squared equal to r squared, not c squared, because usually in math class you call this c, but in physics I just call it r. It doesn't really matter. So to find r, just square root of a squared plus b squared, that will give you r. And so a is referring to this line right here, so that would be 3, that would be 4, and then square that square root, so the magnitude should be around 5 meters. Not too complicated, the mathematics, not that dense. This one's a little bit tricky if you are not very familiar with sine, cosine, or tangents, but even if you're not familiar with it, if you watch my previous video, you should remember that tangents is nothing more than opposite over adjacent, just the rule, okay? Just remember that. So that's tangent's opposite is 4 divided by 3. Tangent of the angle is the opposite, which is 4 divided by 3, and that will give you tangent inverse 4 divided by 3 gives you approximately 53 degrees. Yeah, make sure you put in your scientific calculators and put it in degree, not radians. If you see decimal, when you put this in, then you need to change the scientific calculator mode to degrees, okay? Moving on to the next problem. This one is just 3 vectors instead of 2. It's the same process, try it yourself. Like before, I create a sketch of the resultants and also write down what I need to find, which is the angle to magnitude and directions. And so I know that this resultant line is a combination of the x component and the y component. So I need to find this x piece, and that's x piece, wait, y piece. This x piece is nothing more than 5 because that is 5. So 7 plus 5, that would mean 12 meters. And this is line, I wonder what is the length of this line or displacement of this line. It's 5, come on, simple stuff. So that would be 5 meters. So if you go back to the previous method again, a squared plus b squared, and then that will give you 12 squared plus 5 squared, square root of that. That will give you the magnitude of this line is 13 meter. Whoa, amazing, 13 meter. Not really. Same process, just more vectors. Tangent over inverse, again, that will give you approximately 23 degrees. Okay. In my earlier lecture video, I talked about this horizontal line right here is the reference line. So when you say 23 degrees, people automatically know that you're referring to you're going counterclockwise. Okay, so if you go clockwise, you have to mention, but if you say 22 degrees, most people in physics know that it's counterclockwise. Okay, so we go from 2 and now 3 and then 2, 3, and now we go to 4 vector. Whoa! Now it's so hard. Try yourself, see if it's actually hard. Same process for this, even though it's just 4 vectors, line 1, 2, 3, 4, it's the same process. Create a sketch of the resultants. And also, you need to draw that dotted line because this resultant combination with x component and also the y component. So what is this x component? What's this missing piece? Oh, wait a minute, it's down here. Wait, it's 5 meters. So what is this? I don't know what it is. Such a difficult mathematic. No, it's not. This entire line is 12. So this is 7. It's 12 minus 7. That will give you 5 meters for this dotted line. Not too complicated, okay? Same process from a squared plus b squared again, like the previous problem. This is 7 plus 5, that gives you 12 square, and then that b is 5, And so that will give you the magnitude of 13 meters. The tangents opposite over adjacent angle opposite is 5, adjacent is 12. So that will give you the angle of 20 degrees counterclockwise. Yep, you have to mention counterclockwise, otherwise physicists will go the other way. I mean clockwise, you have to mention clockwise, otherwise physicists will assume it's counterclockwise. But if you solve a problem on a sheet of paper and you label the angle, then it's obvious that's what you're referring to. Okay, moving on to something a little bit different than the previous one. The previous one we do 2 vectors, 3 vectors, 4 vectors. Now let's just find the components instead of finding the resultant, right? It's giving you this vector, which is, let's just say this is the resultant. What is this component and what is that component? Okay, they give you the angle and that. Okay, if you're completely lost and have no idea how to approach this, you need to watch my lecture video and take some notes. Pause and see if you get the same answers that I will. So a little bit trick here, dx. You can call this whatever you want. You can call this x, dx, vx. Doesn't matter. It's just a variable. In the x component here is 12 cos of 30 degrees. That will give you 10 meters. That's the answer should be. dy is 12 sine of 30. That will give you 6 meters. Plug in the calculators. Okay, no one know what sine 30 degrees. Well, yeah, you should know what sine 30 degrees if you take math class. But if you don't, just put in a calculator, no big deal. Give you 6 meters. Excuse me. Yeah, I make a mistake here. I kind of give you the answer before you try it yourself, but no big deal. It's just the same problem as the other one. It's just reversed, okay? So this component is dx is 14 cos of 45 for 10 meters. Is 14 sine 45. Same problem like early one. Sorry about giving you the answer before you try it yourself. It's okay, Mr. Deng. Oh, okay. No problem. Whoever say that. Final components for this one. A little bit tricky, but not too complicated. Okay. So, let's see what we need to do first. How do we know it's 30 degrees right here? Because you know that there's 360 degrees in the circle. Okay, if we go all the way to this point, it's 270 degrees. 207 degrees minus 240 degrees, that gives you this angle 30 degrees. Okay? And the rest is easy. Now that you have this angle, then the rest is just so easy. Same as the previous one. If you find this to be difficult, I'm sorry. It's just that you might miss a few math class about sine and cosine. But you review, I think it'll make more sense. There will be 12 sine of 30 degrees. This one is 4. Oh, I make a mistake here. So this should be 12 cos of 30 degrees, not 14. I made a mistake. My apologies. But this process is just the same here. It's just dx is 12 sine 30, and dy should be 12 cos of 30 degrees. No, I did not make this mistake. The sign right here is actually correct. 12 sine, not 12 cos, okay? If you remember from previous one, well, just remember sine. Sine is opposite of a hypotenuse. So therefore, I'm using sine. And cos is adjacent of a hypotenuse. That's why I'm using cos. The only mistake here is this shouldn't be 14. This should be 12. Okay, plug in 12 here, cos of 30 degrees. See if you actually get 10 meters. If not, then just change the answer right here. Okay, moving on to this one. This one's a little bit more complicated than the previous one. Try it yourself. So I just draw an extra line right here because the resultant is a little bit longer. The x component is a little bit longer, so I draw that. And I know it's 4 meters because just bring this number down. And I need the y component to solve this problem. So this y component is the same as this one. And I have the angle and I have that. But let's worry about the x component first. So dx should be 10 meters. How did I get 10 meters? I'm using the same equation like the previous one. This is 12 cos of 30 degrees. That will be the 10 meter right here. And this line is dy is 12 sine of 30 degrees. And that gives me 6 meters. And then that will be the same as this one. So you probably bored by now, but same process that you should have 20 meters for the magnitude of the resultant, and you should have the angle of 17 degrees. I think this is the last problem. If you got everything by now and you get a hang of it, good. But if you don't practice this problem, the more you practice, the better you're gonna get at it. The faster you can do too. On the test, you don't really want to think. You just want to just do it like this, okay? And you should can do it in your sleep. That's why we practice, so you can do it in your sleep. Not that you want to sleep and do this in your dream, which is awful. You want to dream about something else rather than physics. But some people prefer to dream about physics and math. That's up to them. Okay, so, so you draw a resultant again, and you need to find this angle. And so, first I have to find this line, which is 14 cos 45 degree, because this is 14 and that's 45, so this line should be 14 cos of 45 degree. And this long line right here is 14 sine. If you, doesn't matter if you cos or sine, you do 45 degrees, pretty much you get the same answer, 10 meters here. So same process. Some of you probably wondering, where did I get 19? Well, think about it. This line is 9 and that's 10. So 9 and 10, this line would be 19. So that's why it's 19 squared. And this line is 5, not 10, because this whole line is 10. Entire line is 10. So 10 minus this line, that will give you 5, this part. And so you plug it in, 19 squared plus 5 squared, that gives you 20 meters. Not too bad. And the angle again is opposite of adjacent 5 right here, divided by 19, this whole entire line. Sorry if I put 14 too close to this dotted line. This 14 is for this blue line, not this dotted line. Okay, so you plug 5, 9, divide by 19, tangent bird, that will do 15 degree counterclockwise. So that's pretty much it. If you notice that I plug in the number in the calculator wrong, just by all means fix it. Don't doubt yourself. If you paying attention, the process is just similar. It's pretty much the same of finding the resultant magnitude and directions. Also find the x component, y component. The process is the same. The problem can seem complicated because they might add more vectors to it, and you have to use a combination of trig and maybe angles and just, all those stuffs make it seem it's too complicated. But always step back and ask yourself, okay, I need to create a sketch. I need to find the x and the y component, and then I just use this a squared, b squared, and tangent inverse. In case in which I'm not trying to find the resultant magnitude and direction, but I'm trying to find the x component and y components, the method of dx and dy will apply, okay? So that's all for this video. Finally, hopefully I click record. If not, I have to repeat this. Okay, bye everyone. See ya. Have a wonderful day.